We're going to be talking about slope today, which you know as slope describes the rate of change of a line. Okay? You know it as, it's also known as, you know, AKA means that, right? Is that far enough in? Okay. It's also known as, let's see if my thing will refocus here. Come on. No, I don't want that. Come on, focus, focus, focus. Autofocus. There we go. All right.
Like autofocus when you would write.
Yeah.
It would go blurry, and when you move your hand, it would go
Yeah, I know. All right. So, it's also known as AKA unit rate. That's what you've known it as unit rate or rate of change. It's also the steepness of a line. In other words, you can graph anything out there in the world. How much you pay per gallon of gas, okay? That is going to be a straight line. That's a linear equation because you have this amount for every unit of gas, whatever you're comparing it at. And you could graph that and it will make a straight line. So what we're talking about are linear equations, straight line equations, okay? If you have a quadratic, it looks completely different. An exponential looks completely different. But all you've known about so far are linear equations, all right? This is the rate of change. All right, let's see here. There are several ways that you need to recognize slope. And the two ways we're going to talk about today are from a graph and from an equation. We're going to pick these notes back up tomorrow, and we will do from a table and from 2 points, okay? Because they're essentially the same thing. From a word problem, we'll talk about, but we're not going to get really deep into it at this point. So, how you find slope is rise over run, okay? You can also, it's known as the change in y over the change in x, okay? Or we have a formula, and you have this formula on your chart. So I would like you to open your binders to that pink formula chart, and we're going to talk about this more tomorrow, but I want you to know where it is, all right? From 2 points, you use y2 minus y1 over x2 minus x1, okay? And if you notice that formula, it says slope of a line, and that formula is on your chart, yes? Okay? All right. So if I had 2 points, you have an x and a y for each point, correct? So we'll get to there tomorrow. We're going to really specifically talk about this rise over run today. And from an equation, it's a piece of cake. All right? So you choose 2 points on the graph. You count the rise, and I'm going to demonstrate that, from 1 point to the next. Then you count the run, okay? You write the slope as y, which is your rise, over x, which is your run, okay? And you guys, I'm sure, will be just fine with this. There are a couple of keys to this. And the reason I gave you this nice big graph paper is because I wanted to demonstrate something, and these are a little bit small, and I wanted to show you on a nice big piece of paper. What we're going to do is, for right now, we are going to put points on these corners, and we are going, and I know I didn't give you a ruler, probably should have, But I'm just going to kind of do this as best I can, make it kind of look straight, and just kind of connect my points with a line. By the way, this is the parent function of a linear equation. This line is called y equals x. All right? And we're going to learn a lot about those kinds of things. All right? So, to count slope, what you do is you have to pick a point on this line, and these points won't always be there. All right? They're not necessarily going to be, they're not going to have dots on it. You're just going to get a line. The key here, though, is you have to pick a place where the line crosses, and I'm going to use this down here as the example, where all the lines on the graph intersect. Okay? Do you see how this line and this line intersects, and you have to choose that as a point? Okay? So I'm just going to be doing it easy, and I'm going to choose this one right here. I'm going to make it real dark so we see it. All right, and I'm going to choose this one right here. And what we do is we draw a triangle, and it's a right triangle, and we're going to draw up. So remember I said we're going to do rise over run. Your up movement is if you notice, I'm on the y-axis. I'm going up, all right, and I'm going up how many? 1. Okay, so that would be my rise of 1, all right? And then I'm going over, which is across my x-axis, so that's your run. How many? How many did I go when I went from here to here? 1. And 1 over 1 is equal to what? 1. So my slope of this line is 1. Now, I can prove that anywhere on this line, if I was to draw from one point to another, and I'm going to get something that will make it easier for you to see, if I can find a sharpened pencil, colored pencil here. All right, let's say I drew from this point down here, and I didn't see that these crossed, so I went all the way over to here, okay? And I went up, I'm going to draw my triangle, and I went over, okay? So now I have a right triangle. These are called similar triangles because they are both right triangles, and they are on the same line. All right, they're known as similar triangles. So now I'm going to start here, and I'm going to count my rise. 1, 2, 3, 4, 5, 6. All right, so my rise is 6. I'm going to write this over here on the side so I don't forget it. Okay. You start, and you know you count as you pick up your pencil. Everybody knows that, right? I don't count 1. The first time I count is when I lift and hit. 1, 2, 3, 4, 5, 6. So my run is 6. Now, if I write it as rise over run, I'm going to get 6 over 6, and when I divide 6 by 6, what do I end up with? 1. So it doesn't matter what points I choose on the line, I'm going to come up with the same slope. The steepness of this line is the same no matter where I'm counting. Okay, everybody get that? So I could choose this one, you could see this one. It doesn't matter. You always simplify your slope, and when you simplify your slope, you're going to find out that it will end up being the same. All right? So the steepness of a line is your slope. That is how much whatever you're talking about is going up for how much. And usually on like a graph, if you're not just talking about slope, you would have these are gallons, and this is the price, and this is the gallon, right? And you could say, okay, well, it's 1 for each gallon, correct? Okay, all right, pretty simple, yeah? All right, so then let's look at these two little ones here. So you're going to pick 2 points, all right? It doesn't matter if you pick the same as I do, but you notice that I cannot pick this part right here. Do you see why? It's not in where the intersection of your X and your Y axis, okay? So I'm just going to pick this one, and I'm going to pick this one. If you happen to get lucky enough to pick the closest ones that you can find that do intersect, you will usually not have to simplify your slope, okay? So I've got rise over run, and I want you to write it every time for now. And I'm going to draw my triangle, and I'm going up 1, 2, and over 1, and I end up with a rise of 2 and a run of 1, which means my slope is what? 2. Okay? Now, we'll talk about an equation in a minute, okay? And we'll get to that. I shouldn't throw it out there quite yet. All right? Now, the thing you need to know, when you have a line that is in this direction, okay, there's a difference. This kind of line going up from left to right is a positive slope. If your line is going down from left to right, it is a negative slope. So let's note that here. Up, left to right equals positive slope. Okay? Down, left to right, just like you read, left to right, okay, equals negative slope. You want to get in the habit of always rising first and then running. I know that here it would look like it would be easier to go across and then over, okay? The reason that you don't want to get in that habit is because if you do, you will tend to put run over rise, and it'll be wrong, okay? It's always got to be that rise over run, and if you build that habit to learn it's okay to go up and over to the left, that's your other indication, by the way. I'm sorry, it's over on the end. Okay, your other indication that it is negative is I had to go left, okay? Here, I went up and then to the right, didn't I? Okay, so to the right is positive. To the left is going to give you a negative slope. So here when I do rise over run, I go up how many? 1. And I go over how many? 1, 2, 3. All right, so it's a negative 1 over 3. Now, the negative sign, does it matter if I put it on top or on bottom? No, okay? So if I was to write that, and I'm going to just take this piece of paper, I can rewrite that. I could write it with it definitely on the top. I can write it with it definitely on the bottom. It all means the same, or I can just stick it out there in no man's land, all right? But be careful, don't let it connect to your division line, all right? Because that is a division sign right there, okay? Even though you probably don't. Do you guys recognize that? I hope. I've been trying to get 6th and 7th grade to say those words every time they talk about a fraction. It's 1 divided by 3. 1 divided by 3. Because we used to have a problem. Students didn't understand that that's what that was. And I just have been trying to work on that over the years. All right. Seem like it couldn't be any problem? Okay. All right. Let's talk about from an equation. First off, look at your mathematics charts. Okay? And it says the equation must be in slope-intercept form. Do you guys see a slope-intercept form of an equation? Okay. What that is y equals mx plus b. Now, I know this is a lot to take in, but I'm trying to make sure that I get everything. So, on the back of here, before we move on, y equals mx plus b can also be y equals mx minus b, and I want you to get stuck in that plus. It also can just be y equals mx. The difference is this, and we're going to talk about that in a minute, I think. Okay, but I just want to bring it up now. B is your y-intercept, and we're going to talk about y-intercept in a minute. All right? So your y-intercept can be a positive number, it can be a negative number, or it can be 0. And when it is 0, then that means that your line or your equation is starting from 0 and it's going to intersect the origin on a graph. And we don't write it, we don't write y equals mx plus 0. We just leave it off. Remember, I keep telling you we're lazy mathematicians. We just leave it off. But if I have an equation like this, I know that my line or my starting point is 0. I'll give you an example. When I start from my house, and I drive to school, I'm starting at 0 miles. So if I wanted to find out how many miles per hour I drove, my graph would start at the origin 0, 0, okay? And if I drove 60 miles in 1 hour, then that would be 60 over 1. 60 would be my slope. M, the slope, is represented by M. Okay? So M represents slope. Slope is always the coefficient of x. Do you know what a coefficient is? A coefficient is something that's right next to it. It's cohabitating. Think about that word, what cohabitating means, okay? So when you see this equation, y equals mx plus b, m is your slope, x is your variable, and b is your y-intercept. Okay? X is your variable. It could be a v. It could be a g. But we represent it as an x in most instances. Okay? M is your slope. So if I look at this right here, y equals 4/3 x minus 12. M, which is my slope, is equal to what? The letter M represents slope. What is it? What is the coefficient of x? 4/3. Okay. Here, M is what? -3. It's whatever is right next to x. Here, M is what? 15. Your slope is 15. Okay. Here, M is what? -0.1. I'm going to give you one other example. Y is equal to x plus 5. What would your slope be? What's next to x? Remember, we're lazy. We don't write it, but there is a coefficient of x. It's that 1. Okay? Let's flip this paper. And let's look at y-intercept from a graph. Okay? Your y-intercept from a graph, we've got a line. Okay? Here's my line. My y-intercept is this, everybody knows this is the y-axis, right? Okay? This is your y, this is your x-axis. The y-intercept is where that line crosses the y-axis. So first, find your y-axis. Find the point where the line goes through the y-axis. Write the value of that point. What is the value? -1. And we identify in a slope-intercept form equation, because remember, we got y equals mx plus b for our slope-intercept equation. B is our y-intercept. Okay, so B is the y-intercept. All right. M was your what? Slope. Okay. So B is equal to -1. It's that simple. Okay. So on this one, where does my line cross the y-axis? 0. So here, B is equal to 0. Okay? That is your y-intercept. Okay? And I'll do a big one. Y is equal to mx plus b. So this is your y-intercept. Okay? This is your slope. And your x just represents some number. We don't know what it is, and that's why we call it a variable. Okay? Because it represents some number. All right? I can plug in any number I want and change the answer to this equation, couldn't I? Okay? Sometimes if you're solving for x, it has to be a specific number. But I could change the y value, because what it totals. Y is always your total. Okay? What this equation equals is your total. Have you guys had any exposure to this equation? A little bit, but not to this depth. Have you heard the term y-intercept?
Yes.
Okay, that's good. All right. Okay. Like I said, I'm on a learning curve here, so just with you too. So I'm going to be asking you questions like that sometime, just to kind of get my feel. So if I had b was equal to 0, this equation would only be y equals mx. All right. And what it would be, this equation for this line, my equation actually would be y equals 1x, or y equals x. And remember, I told you this was the parent function for a linear equation. That's why the equation would be written y equals x. Because remember, your slope is 1 and your y-intercept is 0. Okay? And it's called the parent function of the linear parent. I should do linear parent function. Okay, is y equals x. That's your equation. This would be your graph. And linear means what kind of line? Straight. Okay. All right. In an equation then, right here, y equals -4x minus 6. What is your y-intercept?
-6.
There you go, right there. So b is equal to -6. It's also known as your constant. Okay, that's your y-intercept. All right. All right. So what is the y? What does it represent? The total. What does the -4 represent? Slope. And your x is variable. And your -6 is your y-intercept or your b value. Okay? All right, I'm going to give you your work for today.